In the last video, we ended by looking at the difference between solubility in terms of temperature for gases and solids. So we said that as temperature increases for gases, the solubility actually goes down. That's why when you leave a soda out and it gets warm, it becomes flat. All the carbonation and the gas that's dissolved in it leaves. But it's opposite for solids. So when we heat up a solid, it can hold more solute. So in order to determine the amount of solute that can go into solution, we use something called a solubility curve. And so you can notice here that we see that trend between the gases and the solids. So the gases are all the dotted lines, whereas the solids are the solid line. So on our axes, we see it says we have grams of solute per 100 grams of water. So this 100 grams of water just means that we have a very specific amount of water. If we had more water, obviously we'd be able to dissolve more solute. So we don't want the water to be a variable here. So we keep the amount of water constant. And so this axis is telling us how many grams of sugar, how many grams of carbon dioxide, or how many grams of sodium chloride could be dissolved in that specific amount of water. And we graph that versus temperature here, so as we increase temperature. So you can see all the gas curves slope down. So as we increase temperature, the gas line decreases, the amount of gas decreases. Whereas the solids, if we increase the temperature, we see all of those curves go up as we increase the temperature, because solubility is affected by temperature. Now, we can also use these types of graphs to figure out exact amounts. So again, it says, notice that the y-axis says grams per 100 grams of water. So this is grams of whatever specific solute the curve is representing. So this would be sodium chloride, this is potassium bromide. So we could be asked questions like this. So it says, at 60 degrees, how many grams of potassium bromide dissolve in 100 grams of water? So again, the 100 grams of water is just a constant. So we would go over to 60 degrees and up to the line that is potassium bromide here. And we can see that it tells us that it's going to dissolve somewhere near 90. So about 88 grams of potassium bromide can dissolve in 100 grams of water at 60 degrees Celsius. Now, if we were to increase the amount of water, then we could also calculate that using this equation, or using this graph. So if we have 88 grams can go per every 100 grams, let's say we increased the water to 300 grams, we've multiplied it by 3 times. So that means we could also hold 3 times the solute. So if I just took 3 times 88, I know that I could dissolve 264 grams of potassium bromide in 300 grams of water at 60 degrees Celsius. Now, when we add a solute to a solution and the max amount that it can hold at a specific temperature, we say that that solution is a saturated solution. Now, if the solution could hold more than we have dissolved in the water, then we call that unsaturated. So if we go back to this example, if we put exactly 88 grams of potassium bromide in this 100 grams of water at 60 degrees Celsius, we would say that it's saturated. So it falls right on the line. However, if we put anything less, anything that was below that line, say 50 grams, then we could dissolve more, and we would call that solution an unsaturated solution. Now, we also can make such solutions that are supersaturated. So that means they're holding more than they could at that specific temperature, or more than they should at that specific temperature. And in order to make a supersaturated solution, you actually heat the solution higher than, for this example, we'll say higher than 60 degrees. And so let's say we heated it to 80 degrees. At 80 degrees, we could dissolve almost 100 grams of potassium bromide. Then if we were allowed that solution to slowly cool to 60 degrees, it would stay in solution and we would have a supersaturated solution. So this is what happens when honey is made. So pollen is taken back to the beehive, and the bees create a really hot temperature, by flapping their wings, and inside the hive it's very warm. And so they melt the pollen, and as we remove the honey from the from the hive, then we allow it to slowly cool, and honey is an example of a supersaturated solution. Now, if you leave honey on the shelf for a while, eventually what ends up happening is the sugar in it starts to crystallize out. And when this happens, it's caused by what we call a seed crystal. So one little bit of the solute starts to come out of solution, which then causes the rest to come out of solution. Now, if we wanted to re-liquefy that supersaturated solution, we could just heat it up again and then allow it to slowly cool, and it would again be holding more solute than it should at that specific temperature. Now, if we look again at the curve, we can determine based on this curve whether or not a solution is saturated, unsaturated, or supersaturated. So again, we're using the example of potassium bromide, and it says at 45 degrees Celsius, if you have 100 grams of potassium bromide in water, is it saturated, unsaturated, or supersaturated? So if we went to 45 degrees and up to 100 grams, we would be right here. And so you notice that you are above the line for potassium bromide. So that indicates that you have a supersaturated solution. It should only be holding 80 grams, but it is holding 100 grams. Now, if we were to add a seed crystal and we were allow that excess to come out of solution, we could figure out how many grams would actually crystallize or come out. And that would be whatever you have in excess. So in this case, we have 100 grams when we should only have 80. So if we added a seed crystal, 20 grams would come out of solution. Now here's another example. Let's say we have 10 grams of potassium nitrate at 20 degrees. Is the solution saturated, unsaturated, or supersaturated? So we go over to 20 degrees Celsius, and we go up to 10 grams, and we see that we're falling under the potassium nitrate. So here's the curve for potassium nitrate, and so we fall below. So if you fall below, that would be considered an unsaturated solution. All right, so in class you're going to be working with a solubility curve and answering questions to interpret amount of solid as well as determining saturated, unsaturated, and supersaturated solutions.